Hey, my name is Felipe and welcome to my channel. In this video, I'm gonna show you how to train an object detector using your own custom data with Yolov10, and I'm gonna show you the entire process from how to do the data collection, the data annotation, how to train the model in your own local computer or in a Google Colab, so it's going to be 100% free. I'm also going to show you how to evaluate the model you trained and how to make predictions. So this is going to be a super comprehensive tutorial, and now let's get started. So let me get started with the data collection. Let me show you the data I have downloaded to use in this tutorial, and this is the data I'm going to use to train the object detector. So I'm going to train an object detector to detect ducks. So you can see these are many different images of ducks, right? And the first thing you need to keep in mind when collecting data to train your object detector is that you are going to need a good amount of data. You know, I work as a computer vision engineer and I work as a freelancer. I provide my services as a freelance contractor, and you will be surprised with how often clients approach me and tell me they have a problem with the object detectors they trained in their projects, and when I ask them how many images they use to train the object detector, they tell me something like, oh no, we used a lot of data, we used like 20 images, right? They usually tell me something like that they used like 10 images or 20 images, and that's the first thing you need to keep in mind. In order to make it work, you are going to need a good amount of data. Using only 10 images or 20 images, something like that, is not going to work, right? You are going to need a lot of data to train this object detector, and the exact amount of images you need is going to depend on many different factors, and it's going to depend on your specific project, but I will recommend you to have at the very least a few hundred images, a few hundred, perhaps a few thousand images, and if you do so, then it's going to be more likely that you are going to train a very robust object detector. Then another recommendation I can give you regarding the data collection is that you need to make sure you have a very diverse data set. Let me show you some of the images I have downloaded to train this object detector. You can see that all of them have ducks, but you can also see that all the ducks in these images are very diverse, are very different from one another, right? You can see that their colors are different, their sizes are different, the background is different, absolutely every single thing is different, right? All these images are completely different. We have different type of ducks, and absolutely everything is different. In some images are in black and white, other images are like cartoons, so this is definitely a very diverse data set. This is also something very important, because remember that when you are training an object detector, you are teaching the object detection technology what's the generic structure of the object you want to detect. So you want to have a very diverse dataset, because this is going to help the object detector a lot to understand what exactly your object is. This is going to teach the object detector what are the most important features of your objects, right? If you have many different images and in absolutely all your images the object is always of the same color, for example, then that may be a little confusing, because that may teach the object detector that your object is always of that given color. Or perhaps if the background is always the same, that may be a little confusing too, because the object detector may learn that the background has to be the same. So you always want to have a very diverse data set, and you want to have many different samples, and you want to have your object from many different perspectives and from many different point of views and many different sizes, colors, backgrounds, and so on. Make sure your data set is very diverse, and that's going to help you a lot in order to train this object detector. So these are the most important considerations regarding the data collection. Make sure you have a good amount of data to train this object detector, and also make sure your dataset is very diverse. And in my case, I am going to use 500 images to train this model, and I already show you the good amount of diversity I have over here. So this is going to be an amazing dataset to use in this project. Now, I'm going to show you a very generic process, and I'm going to give you some some very generic recommendations you can use with whatever dataset you want, right? Everything I'm going to show you in this tutorial is going to work exactly the same for whatever dataset you may want to use. But if you want to follow along this tutorial and you want to use the same dataset I am going to use right now, you can download exactly the same dataset from the Google Open Images Dataset version 7. So if you want to use exactly the same data I am going to use in this tutorial, the only thing you need to do is to go here and then you need to click in the download section, and you just need to follow the steps which are provided over here, and you will be able to download this same dataset I am going to use in this project. But remember, this is also going to work for whatever other dataset you may want to use in this project, so you can just use whatever data you want. Now let's continue. Now let's move to the next step in this process, which is the data annotation. And this is very important. This is amazingly important. This is perhaps one of the most important steps in this process, because the data annotation is where we are going to define what exactly our object is, right? Where exactly our object is located, and this is what's going to tell the object detection technology where our objects are located within the images. I'm going to show you exactly how to do it in a few minutes. We are going to use CVAT, which is a computer vision annotation tool. This is an amazing tool. I have used it many times in many projects, and we are just going to use this tool in order to annotate this object detection dataset. So the first thing you need to do is to log in into your account. If this is the first time you're using CVAT, then it's going to be completely empty, obviously. So let's create a new project. We need to click here on projects and then create a new project. I'm going to name this project duck detection, and I'm going to add a label which is duck. Okay, and I'm going to click here on submit and open. Okay, everything's okay. This is the label we created, and now I'm going to create a new task, and I'm going to upload a few images so I can show you how the annotation process works. I'm going to name this task 0001. The name doesn't really matter, you can just choose whatever name you want. And I'm going to select a few images to upload over here. Perhaps I can just drag the files over here. In order to show you how this process works, I'm going to annotate only a few. Obviously, it doesn't make any sense to annotate all the 500 images because it's going to take me a lot of time and it doesn't really matter, right? I'm just going to show you how the overall process looks like, and I'm going to annotate something like, I don't know, I'm going to select these images over here, and I'm going to select them, and I'm going to drag and drop over here. Okay, and then I'm going to click on submit and open. So this is the task we have created, and now I'm going to click over here. So let me show you how to draw a bounding box around each one of the objects in all of these images. This is very important because this is how we are going to produce the annotations we need in order to train this object detector. So the first thing I'm going to show you is how to draw all these bounding boxes. We're going to click over here in this rectangle, and then I'm going to click here where it says shape. And now I'm going to enclose each one of these objects like this. For example, this one over here. So I'm going to do something like this and like this. Okay, so this is the first object I have annotated. And now I'm going to do exactly the same for these two ducks over here. I'm going to press the letter N, and this is going to be a shortcut in order to draw new bounding boxes. Now I'm going to do the same for this duck over here. And I'm going to do the same for this other duck over here. Okay, so the bounding boxes don't need to be 100% perfect. For example, something like this will work just fine, right? And over here, for example, if we do something like this, it will work just fine too. So the bounding boxes don't need to be 100% perfect. Just make sure you are enclosing the object, right? Now let's continue. What I'm going to do now is to go through all these images one at a time, and I'm going to annotate all of them. And every time I see something which I think it's important, I'm going to post the the annotation, and I'm going to give you my recommendations, and I'm going to show you a few things which are very important, because the annotation process defining exactly where the objects are located, although it seems like it's very easy and it's very straightforward, trust me, it's not as easy as it sounds, and there are some cases in which you need to have a very well-established criteria in order to annotate your data. But I'm going to show you with a few examples. So I'm just going to pause the video here, the recording here. I'm going to keep on annotating more images, and I'm just going to resume this recording when I see something interesting, right? Because I'm going to show you a few recommendations. I'm going to give you a few insights which are going to help you a lot in your annotation process. Okay, for example, over here, there's something very interesting, very important. You can see we have two ducks here, and also we have another duck which is over here, and perhaps we have another duck over here. I'm going to delete it for now. I'm going to do it again in a few seconds, but only for you to see this part over here, which I'm not sure if this is a duck. This is a duck for sure, but this other thing over here may be a duck too. I'm not sure. But regarding this one, you can see that we are not really seeing this duck at all. We have like a huge occlusion, and we are not really seeing it at all. So my criteria in this case is to not annotate this duck over here, and I'm just going to focus on these other ducks we have over here, right? There will be many cases in which you are going to have some huge occlusions and you are not going to see a few of your objects. And also there will be a few cases in which there will appear to be an object in the background, but you're not 100% sure. So in those cases, you need to have a criteria and you need to make a decision. For example, in my case, I'm just going to annotate those objects which are very well defined, and I'm not going to annotate everything that's like in the background with a huge occlusion. And this is another example, because you can see that we have many ducks over here which are very well defined, but then we also have other objects over here which have like a huge occlusion, and we are not really seeing the duck at all, right? I can see that there is something over here and this is a duck, but I don't really see the object, right? And if I go over here, you can see that there are many other ducks in the background which are very small, very pixelated. So in my case, over here too, there's a huge occlusion. In my case, I am not going to annotate all these objects over here, and I'm just going to focus on all these other objects which are much more noticeable, right? Like this, and then like this, and like this. Okay. So remember, my criteria in this project is to only annotate those objects which are 100% visible and without these huge occlusions, right? This is what I mean regarding the annotation process is not as easy as it sounds, because there will be many cases in which you are not going to be 100% sure if this is the object you want to annotate or not, and you're going to make a decision, right? And it's very important, whatever decision you make, this is super important, because now it's the time in which we are defining exactly what's the object we want to detect. So if our definition is not clear, it's going to be very challenging for the object detector to understand what our object is. Right? See what I mean? This is why the annotation process is one of the most important steps in this process, and it's perhaps the most important step in this process. We are going to define exactly what's the object we are going to detect. Over here, for example, I see I have many ducks over here, and over here. But then I have other birds in the background, but according to my criteria, to my thoughts, to what I think, these are not ducks, right? This is like other type of bird, but this is not a duck, so I'm not going to annotate it at all. And then over here, there's like something, but I don't really see what this something is, so I'm not going to annotate it either. And that's pretty much all. Yeah, that's pretty much all, so I'm just going to continue. In some cases, you are also going to find a lot of objects, right? For example, like this. What I usually do when I'm annotating my data is to have a different bounding box for different objects, right? Like this. But I have seen other annotation criteria, which is just drawing a huge bounding box enclosing absolutely all of the objects or a few of the objects together, right? Once you start having like a lot of objects which are very close together, something like this, I have seen some criteria which involve just drawing a huge bounding box enclosing everything, right? Something like this and like this and like this, right? And basically you are telling the object detector everything that's here is a duck, everything that's over here is a duck, right? And this potentially could be okay too. If you decide to annotate some images like this, then once you are making predictions, once you are making inferences, then you will have some cases in which you are just producing only one bounding box that encloses a lot of objects, right? So it all depends on your project, it all depends on what exactly you are trying to achieve. In my case, I really like to have different bounding boxes for different objects. It takes much more time to annotate, but the results are much better. From my perspective, for the type of projects I usually work with, I like to have a different bounding box for different objects, right? So I'm just going to keep annotating this image, and I'm going to resume the video again once I have something interesting to show you. Now this is another very interesting thing. You can see that these two ducks over here are very well defined. Everything it's perfect. I have already drawn a bounding box around each one of them, but we also have this other structure over here, which, if I'm honest, I don't really know if this is a duck or not. Perhaps this is a duck, or perhaps this is just like something in the water, right? I think it is, but I'm not completely sure. In these cases, you need a criteria and you need to decide what you are going to do, because if you are going to tell the object detector that this object over here is a duck, that's going to teach the object detector that this type of structure over here is a duck. So it's all up to you. Is this the object you are trying to detect? This is something you need to ask yourself. Is this the object you are trying to detect? Because if it is, then go ahead and annotate it. If it's not, then don't do it. In my case, my criteria for this type of situations is to just not annotate it, right? When I'm not 100% sure if this is the object I'm interested in or not, I do not annotate it at all. Remember that you are going to have a lot of data, you're going to have a few hundred images or a few thousand images, and in all of these images you are going to have a lot of objects. And hopefully all these objects, or most of them, the vast majority of them, are going to be very well defined like this. So if you only have a few objects which you are not really sure, it's not going to be a big deal if you don't annotate it. Nothing happens. So yeah, this is also my criteria in this situation. And that's pretty much all. Now let me show you something else, which is showing you how to download this data, right? Once you are done annotating all of your data, all of your images, remember you are going to click save, you're going to save the changes, and then the only thing you need to do is to go here to your tasks. You're just going to select the task you have annotated, and then the only thing you need to do is to export annotations, and you are going to select this format over here, which is Yolov1.1, and then click OK. You could also save the images, but if you have uploaded the images, then I guess that doesn't make any sense to download the images again, right? So if you want to download the images, click here, and if you don't, then don't click there. Then you click OK, and this is going to take some time, but eventually you are going to download this data over here. Okay, now the export is finished, and the only thing you need to do is to click here, and then here, download. Okay, and this is going to download all the annotations like this. Okay, now let's move to the next step in this process, which is preparing the data into the exact format you need to train the object detector. Let me show you. So now let's go back to this directory I have created for this project and let me show you something. This has to do with how you need to structure your data in order to be able to train this object detector. This has to do with the location of all of your files, your images, your labels, and so on. And this also has to do with all the directories you need to create in order to locate all of your files. Let me show you. So you can see I have these two directories. One of them is called images and the other one is called labels. I'm going to open the images directory and you can see I have two additional directories. One of them is called train and the other one is called val. If I open the train directory, this is where I have all my training images, right? The 500 training images I'm going to use in this process. And now if I open the val directory, you can see I also have some images over here, and these are the validation images. These are the images I'm going to use in order to validate the training process. So we have these two directories over here, and if I go back and if I open the labels directory, you can see I have exactly the same structure. I have two folders. One of them is called train and the other one is called val. Train has all the labels, all the annotations for all the training images, and then val has all the annotations for all the validation images. Now, something that is very important, it seems like only a detail, but actually it's very important, and it has to do with the names of all these directories. In order to save you some time and in order to make sure everything works as expected, just make sure you name everything exactly the same as I'm showing you over here. Just to avoid any potential issue in your training process, just make sure everything is named exactly the same as I'm showing you over here. Images, labels, and then this one is called train and this other one is called val. Later on, when I show you the training process, I'm going to show you a file, which is a configuration file, and this file has some paths to the location of your data and your images. So as long as you name everything exactly the same as I'm showing you over here, everything should work as expected, right? Now let me show you something else. If I open the images directory again, and now if I open the training images, and I'm going to do the same for the labels directory, the training labels, you can see that for every single one of my images in this directory, if I order everything like this, okay, you can see that for every single one of these files, we have a given name, a given ID, and then the extension is JPG. And then if I go to the annotations directory, you can see that the file names are exactly the same, but with a different extension, right? You can see that the file names are exactly the same. I'm referring to this ID over here, this ID. Right, this ID over here is exactly the same as this other ID over here, and the only difference between these two file names is the extension, right? And you can see this is exactly the same for absolutely every single file. So this file over here contains all the annotations, all the bounding boxes for this image over here. This is also very important because it has to do with the how your dataset works, and this is going to help you a lot to understand exactly what's going on, to understand exactly what you are doing in this training process. It's going to help you a lot to know more about your data, to be more familiar with your dataset, and this is also going to help you to solve whatever issue may arise when you are training your object detector. And then about the annotations, you can see we have the annotations which are given in this format. This is the YOLO format. The first number is the class ID. In my case, I have only one class in this dataset, which is duck. So in my case, this number is always going to be 0. But in any other case, this depends on the number of classes you have in your dataset. And then this is the location of the bounding box. The first two numbers are the X and Y coordinates of the center of the bounding box. And then this is the width and this is the height of the bounding box. and you can see that everything is given in relative coordinates. So this number and this number over here are divided by the image width, and this number over here are divided by the image height, right? These are relative coordinates. So this is only to show you super quickly how the annotations look like, and also to show you how you need to structure your dataset and how you need to where you need to locate all the files and so on in order to make this training process work as expected. And now let's move on to the training process. Now it's the most fun part of this tutorial, because now it's the time to train the object detector. So let me show you. I'm going to show you how to train this object detector in your own computer, and also I'm going to show you how to train it in a Google Colab. So let's get started with Google Colab. The first thing you need to do is to create a zip file from this directory, right? Remember, this is the data directory. This is where I have located all my data, and the only thing I'm going to do is to zip the entire directory. I'm going to compress the entire directory. In my case, I have already done it. It's this file over here. You can see it's called data.zip, but in your case, please remember to do so before you continue with this tutorial. And once you have compressed the entire directory and you have created this file, the only thing you need to do is to upload this file into a directory in your Google Drive. This is a directory I have created in my Google Drive. It's called Yolov10 Object Detection Full Guide, and you can see that this is the data.zip file I am showing you over here. So this is what you need to do next. Please remember to upload this file to a directory in your Google Drive. And now, in order to train this model, we are going to follow all the instructions which are given here in this Google Colab, right? In this Jupyter Notebook, actually. So the only thing I'm going to do is to execute each one of these cells one at a time, and this is going to take care of the entire training process. So let me show you. The first cell is going to connect my Google Colab to my Google Drive. I'm going to select my account, continue, and that's pretty much all. Okay, now I have connected my Google Drive with Google Colab, and the only thing I need to do next is to execute this cell over here, which is going to copy the file we have uploaded over here into this Google Colab environment. So the only thing I'm going to do is to press enter, and you can see that this is not only going to copy the entire data, but it's also going to uncompress this file over here, and you can see that we have already uncompressed all this data into this Google Colab environment. So now let's continue. Now the next step in this process is to install all the required packages. So the only thing we're going to do is to clone this directory, clone this repository, which is the Yolov10 official repository, and then we are just going to install all the required packages like this, right? We are just going to cd into this directory, and then we're just going to pip install the entire repository. So the only thing I'm going to do is to press enter, and this is going to take care of the entire process. Okay, everything seems to be ready, and we can continue over here. This is the most important part of this process, because this is where we are going to train the object detector. So you can see that the only thing we are doing over here is a couple of imports. We are importing OS, and then we are importing this library, and we're just importing Yolov10. Then you can see I have this path over here, which is a path to a configuration file. Let me show you how this configuration file looks like. If I open this file, you can see I have 3 keys. One of them is the location of the root directory of our dataset, which is over here. And then the other 2 keys are related to where the training images are located and where the validation images are located. This is why I told you that as long as you name all the directories exactly the same as I show you in this tutorial, and if you use exactly the same configuration file, everything should work as expected. And then all of our classes, you remember that the only class I'm going to use in this dataset is duck. I'm going to train this object detector to detect only one class, duck. So in my case, this is how it looks like. And that's pretty much all. Once I have the file over there in my Google Drive, the only thing I need to do is to press enter, and this is going to train Yolov10 from these pre-trained model weights, and it's going to train this model for 200 epochs. So this is going to take some time. So what I'm going to do now is to pause the recording here, and I'm going to resume this recording once the training process is completed. Okay, now the training process is done, and let me show you how to download all the results from this training process. You can see that the results have been saved here in this directory, and let me show you how to download these results into our local computer. I'm going to execute this cell over here which says download results, and this is going to take care of downloading all these results. You can see I have an error. I'm not sure why this error happens once in a while, but if you encounter a similar error in your when you train this model, then the only thing you need to do is to restart the session, and then you just need to press enter again, and this is going to fix the issue. So basically we are compressing the entire runs directory. We are creating this file which is runs.zip, and then we are downloading this file over here, running this command over here. You can see that this is in progress, and once this is done, we are going to download this file into our local computer. Okay, I am just going to download the file in my desktop, and then I'm going to open the file like this. You can see I have a lot of directories, and over here I have all the results from the training process. This is where the weights have been saved. You can see we have two files, best.pt and last.pt, and then these are all the results. Now, this is how you can train this model using a Google Colab, but remember I told you that I am also going to show you how to train this model using your own local computer. So let's go to PyCharm, and I'm going to show you how to do it locally in your own computer. And this is going to be exactly the same process as we did over here in Google Colab. So the first thing you need to do is to create a new virtual environment, obviously, because that's always a very good practice when working with Python. So you can see over here I have already created a virtual environment, and in my case I created this virtual environment using Python 3.9. But in your case you can just use pretty much any other version of Python 3. If I'm not mistaken, pretty much any other version will do as well. So once you have created this virtual environment, you need to clone Yolov10 official repository by executing this command over here. I'm referring to this repository, Yolov10 repository. You can see I have already cloned the repository, and it's over here. And then the only thing you need to do is to cd into this repository, something like cd Yolov10. Okay, and then you need to install the requirements. So pip install, and then this character over here, pip install, like this, and then press enter. In my case, nothing is going to happen because I have already installed all these packages, but in your case, please remember to do so, otherwise nothing is going to work. And now let's continue. Once everything is installed and everything is okay, the only thing you need to do is to execute this code I have over here. You can see this file is called train.py, and these are the instructions we need to execute in order to train Yolov10 in our local computer. You can see it's exactly the same code I show you over here, exactly the same code. The only difference is the location of the configuration file, which now is going to be located here, but other than that, everything else is exactly the same. And let me show you that now this configuration file, there's something different as before, because now this is the path to the data, right? And this is the path to the location of the data in my local computer. If I copy all that value over there and I paste it over here, you can see that this is this current directory and this is where the data is located, right? I'm going to paste it over there and this is data. So please remember to update this value to whatever location you have your data in your file system, right? This is the absolute path to your dataset. And then this is exactly the same, and this is also exactly the same. So then the only thing I'm going to do now is to just execute this file, and this is going to take care of the entire training process. Let's see if it works. Okay, there's a very small mistake. Actually, this is from pre-trained. Like this. Okay, let's see now. We may need to install a package. You can see I have an error over here. In case you have a similar error in your computer, this install over here may fix it. So I'm going to run pip install save tensors, and I'm going to run the same file again. Okay, and you can see that everything is going well and the training process has started over here. So I'm not going to train the model again because I have already did it in Google Colab, but this is only to show you how to train the model in your local computer. Now let's move on and let's move to the next step in this process, which is evaluating the model we trained. It's very important. Every time you train a computer vision model or any type of machine learning model, it's very important you evaluate the training process. So let me show you how to do it. I'm going to take all these results which we have produced from Google Colab. So the only thing I'm going to do is to get this directory over here, and I'm going to paste this directory over here, something like this. Remember, these are the results from the training process we did from Google Colab. So, in order to evaluate this training process, we are going to do it super quickly, and we are going to do it in only a few minutes. We could spend hours analyzing a training process because this could be a very detailed evaluation. But I'm going to show you a very easy way to do it, which is just looking at some of the plots you can see over here. So basically, just make sure that the loss functions are going down as you increase the number of epochs. You can see that I have trained this model for 200 epochs, and something that's very important every time you train a model is that the loss function goes down as you increase the number of epochs. In this case, we have many plots, and if I'm not mistaken, the loss function we care about the most in this project, in this evaluation, is this one over here, because this is the loss function which is related to the bounding box detection. And basically, long story short, if you want like a very quick way to analyze if this is working well or not, just make sure the loss function is going down as we increase the number of epochs. If the loss function is going down, it's likely everything is going well. It's not a guarantee. I mean, everything could happen, and maybe the loss function is going down and you are not training a very good model. It could happen, but at the very least, you need to make sure the loss function is going down. If the loss function is not going down, I can tell you for sure something is wrong with your project. I can tell you for sure, without any doubt whatsoever, you have made something amazingly wrong with your training process. If the loss function is not going down, if the loss function is going up, something is amazingly wrong, right? So at the very least, you need to make sure the loss function is going down as you increase the number of epochs. And then also take a look at these plots over here, which are related to the accuracy with the performance of your object detector. And for these plots over here, you need to make sure they are going up as you increase the number of epochs. So this is a very quick evaluation, a very dummy evaluation, but trust me, this type of evaluation is going to take you very far. Only by looking at the loss function and only by looking at all these plots which are related to the performance, you are going to be able to know a lot about the performance of your object detector. And then another way to evaluate what's going on with your object detector, another way to evaluate the training process is to see how it performs with a few examples. So there are going to be a few files, as you can see over here, which are called val batch 0 labels and val batch 0 pred, and also there will be other files which will be val batch 1 labels and val batch 1 pred, and you may have even more files. And basically these files are going to tell you how the model performs on some very specific images from the validation set. And you can see that here we are looking at the ground truth, at the annotations, the labels. And then if I show you the other image, this is the predictions we got with our object detector, right? This is the ground truth, and this is the performance of our object detector. And you can see that basically it performs pretty well. I would say it's not perfect, but I would say it performs very well. There are a few misdetections over here. This duck over here, we are not detecting it. And then there's also another misdetection over here. We are not detecting this duck. And also over here. All these ducks over here are very small, but nevertheless we should be able to detect them, and we are not detecting them with our object detector. Now let's take a look at these other examples, and you can see that in this case we are not detecting these ducks over here. Actually, these are not ducks, these are penguins, right? This is the validation data I downloaded, so yeah, it is what it is, but I think these are not ducks at all, but it doesn't matter. We're not detecting these two birds, and it seems we are not detecting these two other ducks over there, right? And we also have a misdetection over here, because we are detecting something which is not a duck, as if it were a duck, right? We are detecting like this entire structure over here, and this is not a duck. The only duck over here is this one. I think this is also some other type of bird. I think this is not a duck either, but it doesn't matter. This is the validation data we used to validate our training process. So after this quick evaluation, my conclusion is that the object detector performs very well, but it's not perfect. Now, the next step in this process will be to train a more powerful model, right? Because training an object detector is always an ongoing process, and we will need to go once and again through the same steps. Once we evaluate the training process, if we are not satisfied with the performance of the object detector, then we should go back to the data preparation, to the data annotation, the data collection, whatever. And this is where we should be trying to understand exactly what is going on with our object detector, and we should be trying to decide what are we going to do different next time, right? Perhaps we are going to do some changes with the images we use to train the model, or perhaps we are going to do some changes with the annotations, with the way we annotated the data. Remember, when I was walking you through the annotation process, I told you that we need a criteria in order to do the annotation process, in order to annotate all the images. And different criteria are going to produce different annotations. So this is where we are going to decide the changes we are going to do next time we train this model, and one of the changes could be our annotation criteria, and we could try again annotating the data differently. Right? Now let me show you how to make predictions. So let's go back to PyCharm, and let me show you this script over here, which is called predict.py. This is the script we will be using in order to make inferences on a video. We're going to make inferences on all the frames of a video, and we're just going to draw all the bounding boxes on all the objects we detect on this video. So let me show you how this script works. Basically, we are creating a new model of Yolov10. You can see here I'm importing from Ultralytics, import Yolov10 as YOLO, and then I am just creating a new model like this. I am specifying what's the location of the model weights I'm going to use in order to make inferences. Remember that I have copied the entire runs directory over here, and if I go to runs, detect, train, weights, these are the weights we have produced with this training process. And this is the location I have over here, runs, detect, train, weights, and last.pt. A very quick comment regarding these two files you can see over here. Best.pt means this is the best model which was produced through the entire training process, and last.pt is the model we produced at the end of the training process. There are different criteria to choose either the best model, the best model in the entire training process, or the last model, the one that's produced at the end of the training process. My criteria, what I usually do is taking the last model. So I am going to use last.pt, and this is exactly the location of this model weights. Now let's continue. Then the only thing we're doing over here is loading a video, right, which is located here in video.mp4. Let me show you what's the video we're going to use in this example. We are going to use this video over here, which is just a duck, which is doing nothing, right? It's just being there. This is the video we're going to use in this example. So this is video.mp4, and then we're going to save the results here in out.mp4. Then basically we are just defining these variables, and we are creating this object over here which we are going to use in order to produce the output, right? To produce the video which we are going to save over here. And then the only thing we're doing is iterating through all the frames in the video, and for each one of these frames we are applying the object detector over here, and we are just iterating in all the results we get from this object detector. And then for each one of these results, if the confidence score is greater than 0.5, then we are drawing a bounding box around this object we have detected, and that's pretty much all. And then we just save this frame to this video we're going to save at the end of this process, and that's pretty much all. So this is a very simple process. The only thing it does is going through all the frames, detecting objects, and saving the result in out.mp4. Now let me show you how the result looks like. I'm going to run this video. This is going to take a few minutes, so I'm just going to resume this recording once this is done. Okay, everything is completed. You can see that the video was saved here in out.mp4. So let's see what's the video we have produced. So this is the duck, and now we are seeing all the bounding boxes which are drawn on top. So basically, regarding the performance of this object detector, we can see something very similar as in the evaluation when we were evaluating the training process, because the results are okay, but are not perfect, right? We have a few misdetections, we have a few detections which are not correct. For example, there we are detecting something over here and there's nothing over there. I'm referring to this over here, right? You can see there was a bounding box there, but there's not really any duck whatsoever. So the object detector is performing okay, but it's not perfect. In order to make it perfect, we will need to iterate, and we will need to improve the data, improve the annotations, and we will need to do it again.